Flossie Fletcher was curling her hair when she dropped the curling iron. The curling iron fell 1.651 meters to the floor. Let's draw a picture of what that looks like. So we'll start by drawing Flossie Fletcher. Okay, there she is. And she has curly hair. Or long hair, I don't know. And there's curling iron, and it falls 1.651 meters to the ground. So it's going downwards that way. And it says it was dropped. So that means initial velocity is equal to 0, and it's in free fall. So the acceleration is due to gravity. So that makes it 9.80 meters per second squared going down. Let's start by listing our givens. So we know the initial velocity is equal to 0. We know the acceleration is due to the pull of gravity. That's what's controlling the curling iron to fall down. So that's 9.80 meters per second squared. And I'm not going to give it a sign. I'm just going to do an arrow going down. And the distance it falls, well, it starts at 0 in her hand, and then it goes down to the floor. So I'm going to call that distance down to the floor 1.651 meters. I'm going to have a down arrow. And I want to know how fast it's traveling when it hits the floor. So I want to know that final velocity there. So if I look at this, the arrows all point the same direction, so they all have to have the same sign in the math equations. I can make them all negative, or I can make them all positive. Well, I'm going to make them all positive. Just it seems like that'll make my math a little bit easier. All right, so let's look at the given and see if I can find a relationship for this for part A. I have the initial velocity, I have A, x naught, x, and v. So I'm going to use the v squared equals v naught squared plus 2ax, because this is the only equation that has all those variables that I want in it. And I know that v naught is equal to 0, so what I'm going to do is I'm just going to get rid of that right now. So that's going to be equal to 0. I don't have to worry about x naught. That's not in my equation. So that's great. That means that v squared, the final velocity, is equal to 2ax. So the final velocity is equal to the square root of 2ax. Well, that's easy. So 2 times, again, I'll make everything going down positive, not negative. Just got to be the same sign because they go the same direction. 1.651 meters square root. She's observant to know that height. This will give me a velocity. Velocity is equal to plus or minus 5.69 meters per second. Now, it's going to be positive because I'm assuming everything going down is going to be in the positive direction. So the final velocity is, in this case, 5.69 meters per second. And that's going downwards. Part B, how long was it in the air? In other words, how long was the curling iron in the air? So B, I'm going to find the time. T equals. All right, so I needed an equation with V naught, A, X, and T in it. Now, I could use this velocity over again to 5.69, but if I calculated something wrong, it's just going to give me another wrong answer. So I'm going to try to go back to my original set of givens, the V naught, A, and the X, and looking for T. So what I know from that is going to be our longer equation. X is equal to X naught plus V naught T. Actually, let me redo that in color, just to make it stand out as being different. So X equals X naught plus V naught T plus 1/2 AT squared. Let's get rid of some things to go to 0. So X naught is equal to 0. It says it was dropped, so that means the initial velocity is also equal to 0. So now things are looking nice and small. X equals 1/2 AT squared. All right, got to isolate T, so multiply both sides by 2. So AT squared is equal to 2x. Now divide both sides by a to isolate t. That's equal to 2x over a. So t is equal to the square root of 2x over a. So that's going to be 2 times 1.651 meters divided by the acceleration of gravity, 9.80 meters per second squared. All that's under the square root. Now remember, x and a have to be the same sign because they're going in the same direction. It doesn't matter if you make them negative or positive, they just got to be the same. And then when I do this, I get the time to be 0.580 seconds. And then a 400-meter long train is moving on a straight track with a speed of 82.4 kilometers per hour. The engineer applies the brakes at a crossing, and later the last car passes the crossing with a speed of 16.4 kilometers per hour. Assuming the constant acceleration, how long did the train take to pass the crossing? All right, so I've kind of already started with a little picture here, and I've got the train going across, and you can see on the left-hand side, that's the before situation. And before, he's traveling 82.4 kilometers per hour. So I can actually use Google to convert that to 22.89 meters per second. So up here, that's 22.89 meters per second. And then after 400 meters of the train is passed by, the speed of the train is now 16.4 kilometers per hour, which using Google is 4.4 meters per second converted over. So that would be 4.44 meters per second. Okay, so let's start with our givens. Givens. What do we know? We know x naught is equal to 0. We know that 400 meters of the train has passed before it is slowed down. We know the initial velocity is equal to 22.89 meters per second. That's initial velocity. Final velocity is equal to 4.44 meters per second. I want to know how long the train takes to pass the crossing. So that's a time that I'm looking for. So that's a colloquial way of saying time. All right, so I have all these variables. The one I don't have is acceleration. It's kind of a hint that in terms of my equations, I need the equation without acceleration in it. So I'm going to use this. I'm going to use the fact that the average velocity is distance over time, and the average of any two numbers is v plus v naught over 2. So these two things are saying the same thing. I've got to solve for the time. So to solve for the time, I'm going to cross multiply. That's going to leave me 2x is equal to v plus v naught times t. And then I'll isolate t by dividing both sides by v plus v naught. So I'll move it over here. T is equal to 2x divided by v plus v naught. Great. So that means that t is equal to 2 times 400 meters divided by the initial velocity plus the final velocity, or final plus initial in this case. 22.89 meters per second plus 4.44 meters per second. And then when I do that calculation, I get a time of 29.3 seconds.